Hey everyone. I mentioned in one of my posts that I used some of the technology that could potentially be termed AI, artificial intelligence, and like I said before, artificial intelligence is nothing but a set of programs created to mimic intelligent human functionality, right? Optical recognition, voice recognition, object avoidance, anything that an intelligent human could do if we can mimic it using a complex algorithm, that's artificial intelligence. And the AI effect is where the developers after a while stop calling it AI and it just becomes a program. So a mouse, when it was invented in the 70s, I believe, by Xerox, would have been artificial intelligence. You could literally take your hand and glide it across the table and it will mimic, the cursor would mimic the motion. So it was intelligent, artificially intelligent. Now it's just a program. You get a mouse driver, everybody knows how it works. So same thing with AI. But what I did was I used optical processing, video processing, and the way it works, I will do a video later in the evening. The way it works is in Python, you can use frameworks. I used opencv, which is probably the most popular, most widely used framework for video processing, image processing. And within that, what you do is you grab frames and then you process those frames. So it may look like a video to you, but you are really grabbing individual static frames, performing any kind of processing, and then displaying it back to the user so fast that it looks like it's a video. I've used, so like I said, I've used opencv as over encompassing framework. Within that, I have used, for example, gaussian blur to remove unwanted artifacts from the image, canny edge detection algorithm. Once you detect all the edges, then you can do further processing and then you can do line transformation. So I used something called a how transformation, named after a mathematician back from the 60s, I think, or 70s, Paul Howe. And since then a lot of additions and modifications have been made into that, but it's still called how transformation. So I've used that. I have used other object recognition algorithms. For example, object type recognition. Is it a rectangle? Is it a triangle? Is it a circle? Is different from object recognition if there is a specific thing you're looking for. Matching, right? You have a template and you're trying to match and see if your object matches that template. There is motion detection, which sounds difficult, but probably the easiest or the most how would I say, accurate part of image processing, because going from frame to frame, it's very easy to find out what has moved and what hasn't. So there are a lot of things I have done, and I'll try to do a demo today evening and post it. But it's interesting, and like I said, image processing is only one part of it. There is also I need to do a trajectory path planning for the mower, or I am not using machine learning yet because I don't have, most likely I will not have enough data working on my own system. But if if it becomes commercial system where we receive data from multiple other machines and try to analyze and come up with a algorithm that works for more machines, then we can use machine learning too. But for machine learning, you really need a large data set to draw conclusions, and it continuously adapts to itself, adapts to the new data, and then fixes itself, right? So anyway, I thought I'll start background while driving, because I've been trying to do it for a long time, and when I get time in the evening, I'll do the actual video. So alright, see you guys. Hey everyone, as promised, I'm going to show a little demo of the AI functionalities that I explored, but at this point I'm not really going to pursue actively, because until I figure out what is the micro computer I'm going to use on the machine, right now I'm sticking to microcontroller, so that doesn't have a lot of processing power, and I won't be using a lot of video processing, image processing capabilities. But I do want to show what I have done, because I think it's interesting. People say that I use interesting very loosely, but I hope you find it interesting. Um, Let me see if I can turn this on. Alright, so this is my screen, and this is the main program that I'm using for image processing. So let's start. First of all, you need to define what your webcam is. In this case, my webcam is 1, so I'm using an external webcam to capture information. You define your web camera, you create a window, and actually I should just change it to forever, because I don't need to stop it while 1. And then frame by frame, you capture a frame, you perform certain processing, you display the frame, and then you go on, right? So first I acquire the frame, I do gray conversion, I blur it using Gaussian blur. I talked about canny edge detection, which I'll show you what it does. Then once you have performed the edge detection, I apply how line transform, and once I acquire those lines, then for each of those lines I do certain mathematical calculations. I calculate their sine x, which is really a ratio of height and hypotenuse, and if it is within a range, so I'm trying to see if it's I'm not trying to count vertical lines, I'm only trying to get the horizontal lines. So as long as the sin x is within the range, I show it, I actually plot a line on the actual source image. So let's see how it works. Let me uncomment the source and let's run it. So I have a batch file, save, edge detect. Okay, so yeah, you can see that's me, and for every line that is not a vertical line but a horizontal line, it's displaying this line on the screen, but it's a little hazy, so let's do this. Let me comment these lines first. Okay, go. So this is the initial image, you can see that, yeah. I think I should make this, no, you're fine. So this is without any transformation. Let's start from there, and then so once we acquire the image, let's perform the gray transformation, which I have already done, so the result is gray, and I will show the gray image along with the normal image, right? Now in college I did a little bit of image processing, and gray is literally taking the average of your RGB pixels, so then there is no saturation. It's all numerical calculations, whether it is high pass filter, low pass filter, sharpen, unsharpen mask, um, dithering, blur, Gaussian blur. These are all mathematical calculations, and this is the first very basic that you need to do if you want to do if you want to find some lines. But um, the next step would be to find the edges, and that's my edge algorithm, right? So what I can do is I'm using the gray to perform the edge detection, and once I do that I can display it here. So as you can see, let me move it here, this is the edge detection. It's calculating every edge in the, you see that, in the image, and showing it frame by frame. Where is my command? Let's turn this off. Let's turn off the gray and leave the source and the edge. Now actually before that, let's do a blur. So I have also applied a Gaussian blur on the original image, and I get the result as blurred, so I'm showing it here in a separate window. Let's display that, and then I'll show you what happens after blurring. So this is my original image, and this is the blurred image, right? Now if I take this blurred image and then pass it through the edge detection, the result will be different because all the fine lines will be gone, and that's one thing you need to do if you're really trying to do any kind of object detection. So I'm doing a gray, then I'm doing a blur. For the edge, instead of gray I can pass the blurred, right? Everything else remains the same because at that point edge becomes the, takes the blurred. See how cool this is. Now that all the sharp edges are gone, you can actually see more of a shape, right? You can see that. I could show them side by side, could I? Let me see. Yeah, let's do this here. Let's move this to edge. And then let's call the new window edge 1, and don't use the blur, I'll use the IM. And I should probably comment this one here because that would be too, okay. I think this should work. There you go. So this is the blurred image. You can see side by side. So this one is without blurring. You can see how many edges are getting detected. This is after the blur. You see that how clean and nice it looks, just because I actually, how do we do this? Put it here. This is side by side, and this is my original image, and this is the blurred one. See how cool it is. When you have the original image, there are so many edges being detected, but once you blur it a little, looks totally different. Let me try something else. Instead of Gaussian blur, let's change it to 5 5 and then run it. So now it's a little less edgy compared to the original one, but there is still some noise. So let's go to make it 10. This should give me a clean image. Oops, what did I do? It doesn't like 10. Really? I may have either found a bug or I may have run into a bug. You know what? I can get around it. There you go. 10 was hitting some kind of a limit that I had to avoid. So 11 came out. So now you can see that you can actually detect. Now each of these points can be captured and we can do a manual numerical calculation on these. So if you wanted to see how far the hand has gone, and then the next step would be, so we got blurred and then we did the edge detection. Now let's see if lines come out any better. Actually, we may not see any lines, but let's see. Oops, I need to turn on my line display. So must. What? I didn't need the mask. Alright, let's turn off the edge. And the mask and do this. Right. So now if you see this one, it's showing some lines. It's detecting small lines. I don't know if you're able to see this. See that? It's detecting these yellow lines. I can actually make it easier to see. Line 10111, make it 5. Okay. There. Now you can see thicker lines. So anything that you see in yellow is basically see how it's detecting lines. Now what I could do is print these lines so you can see the number. Should I? Nah, we'll do that later. Okay. So as you can see, we have been able to take an image frame by frame. We have blurred it, applied canny edge detection on it, grayed it, because you cannot apply canny on a non-gray image, that's too much work for the processor, and then performed a how line transform, and I have only taken the horizontal lines. If I changed this to less than -1. If I commented this out and then ran it, then you will see both horizontal and vertical lines. Let's see. There you go. See that? How do I do this? There you go. It's detecting both horizontal and vertical lines, right? But if I control that, I would, if I only was interested in horizontal lines, I could comment this and comment this. And as you can see, it will show a horizontal line, it will not show a vertical line. See that? And I did that because I was looking for horizontal objects in object detection. So as you can see, the horizontal, once I tilt it, the detection goes off. Each of these lines is a numerical number. As you can see, I have been tracking them, and I can use that these numbers 1 0 1 1 1 2 1 3. These are the endpoints of the line, x and y coordinates, and I can use it for any kind of decision making. So that's one. The other thing is you can also put a map on an image. And in normal processing, if you look at an image, generally it's defined as an RGB, red, green or blue pixels. But when you're doing image processing, it's easier to define an image as a specific color instead of RGB. You can do it as HSV. Now the last thing I wanted to show you was not focusing. Okay. Was that what if you wanted to look for a specific object, a specific color of object of a color, right? The way you would do that, okay, my focus is off slightly and I know why. Okay. The way you would do that is you would mask the image with a filter. And in image processing, if you look at any pixel, it's defined as RGB, red, blue and green pixels. What happens is, in image processing, when we do any kind of intelligent processing, it's easier to define a pixel as HSV, which is hue, saturation and value. Hue is what color it is. Is it red, it is blue, it is pink. The same color is going to look different in terms of RGB if you put it under different lighting. But red is going to be red regardless of where you put it. Should be the same, right? So the way we handle that is saturation basically decides how close to gray it is, and value is how bright the image is. So let me show you. In our previous example, let's say, let me first comment this. So in our previous example, let's say we were interested in a specific, I have this screwdriver, it's red. What if I wanted to only see something that's red and exclude everything else and then find its angle, right? What you would do is, even before you pass your image to the Canny algorithm or how algorithm, you would pass it through a filter. So let me do this. In fact, I have already worked out the numbers, so it should be red. Doesn't matter, it's just a variable name, but I'm going to make it red because we are going to look for red. Now for red, the hue is towards the beginning of the number 0 0 to maybe 20 30. I'm going to use 13, make it 15. for its hue. So the hue is between 0 and 15. The saturation is, I'm looking for 141 and 255. So anything beyond 141 is acceptable. Brightness, I don't care how bright the object is. It's I am going to depend upon my hue to do this. So once we define this array of upper and lower limits on the HSV, we create a mask with those filters, and then we pass our image and do a bitwise AND operation. If you remember your digital binary arithmetic, bitwise operator is basically, when you say bitwise AND, it's taking each of your bits. So if your mask is 1100 and the value you are passing is 1000, the first bit is true in both the numbers, so you will get 1. All the remaining bits, at least one of the numbers has a 0, so they get multiplied and they get 0. So it's a bitwise AND. But anyway, we do that, and once we pass that filter, the image through that filter, let's show it and see what happens. Okay. Alright, so this is my result, and as you can see, it has blurred out every other color except anything that is falling in kind of a red. Now if I bring this here, see how amazing it is. It's only showing my red and blocking everything else. Now what I could do is go a little sharper on my hue to remove my face and just leave the screwdriver. So let's do this. Let's make this 10 and increase the saturation. Let's make it 200. Let's see what happens. Ha! My face is gone. Let's see if it detects our screwdriver. Amazing. You see how the resulting image is only showing the screwdriver here because it's filtered. Although I need to increase probably saturation as a little bit. Now you know what, let's leave the saturation and let's increase the hue a little bit. Let's make it back to 20. I think that should take care of it. Oops, my face reappeared. So you get the point. Now what we do here is, I was doing some calculation. After we mask it, let's move all of this up. Let's do it here, and to, you know what, let's move it even further up. Yeah, and to the gray let's pass the res. This is mask, and let's see what happens. It should not be showing that. So all the horizontal lines are coming, but why is it showing my, oh, because my face is still there. I only wanted to see the lines on my screwdriver. Let's see if I can come up with that. Here is the problem. We do the gray here, but for the edge, let's blur the gray, and then we use blurred. Okay. Now the lines are gone. Can you see that? Yeah. The only way I should see a line is if I bring a red. See how amazing it is? I have gotten rid of anything that I didn't want, and all I have is the line showing my screwdriver, which is, if I was really looking for a red object which is horizontal in my image, I have achieved the objective. So that's all it is. Different kind of filters, different kind of masks, and a little bit of mathematical calculation, and you can get what you need. I think. See, now the other thing I could do is that's a problem with the brain that doesn't stop thinking. Um, if L3 minus L1 is not equal to 0, I'm gonna say greater than 20. This should give me longer lines. Ha! Okay, there it is. There was one line. Let's make it 15. It's a little higher filter. Okay. So you have to keep adjusting these parameters until you figure out exactly how you want to do this. Machine learning helps you do that. There was a line. See that? So now the number of lines has decreased, and you really want to get to a point where you only get the line you want. See that? So now if my calculation is correct, and if I was looking for a red screwdriver or a red long object which is horizontal, I found it. See that? I think, yeah. Okay, so that's all it is. Thanks for watching.